Conditional probability. In many real-life problems, you want to count the number of possibilities. For instance, suppose you own a small deli. You offer 4 types of meat: ham, turkey, roast beef, and pastrami, and 3 types of bread: white, wheat, and rye. How many choices do your customers have for a meat sandwich? So you want to figure out all the possibilities. And in order to find all those possibilities, we use the fundamental counting principle. So the fundamental counting principle indicates that if you have 2 events, if one event can occur in m ways and another event can occur in n ways, of course these are just notation, then the number of ways that both events can occur is m times n. So you multiply those two together. For instance, if one event can occur 2 ways and another event can occur in 5 ways, then both of the events can occur in 2 times 5, or specifically 10 ways. You just multiply those numbers together. If you have 3 or more events, the fundamental counting principle can be extended. For example, if 3 events occur in m, n, and p ways, then the number of ways that all 3 events can occur is m times n times p. So you multiply the probability or the cases together. For instance, if 3 events can occur in 2, 5, and 7 ways, then all 3 events can occur in 2 times 5 times 7, which is 70 ways. So you might want to just take some notes off this briefly. You might not need to write all of that down. So press pause if you need to take something out of the fundamental counting principle, and then come back to the video to see our example. So for the first example, we're going to be dealing with a license plate. And number 1 says the standard configuration of a New York license plate is 3 digits followed by 3 letters. How many different license plates are possible if digits and letters can be repeated? So we need to look at the options here. If the first 3 digits, or the first 3 values are digits, you have a choice of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 choices for each digit. So 10 choices there, including 0, 10 choices here, and 10 choices here. Again, those 10 choices are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are your possibilities for a number. After your number, you have 3 letter combinations. There are 26 letters in the alphabet, so there are 26 options for each one of these places. So in order to use the fundamental counting principle, you need to multiply all these possibilities together. So the first digit has 10 possible ways. The second is 10 possible choices. The third is also 10 possible choices. Then we have the fourth placeholder, which has a possibility of 26 different choices. 26 different choices for the 5th spot and 26 different choices for the 6th spot. Multiply all of these together and you end up with quite a large number. You end up with 17,576,000 different options for plates. So this is the number of different license plates that New York can create with this letter and digit combo. It's quite a bit of possibilities. For part B, it says how many different license plates are possible if digits and letters cannot be repeated? Okay, so let's take a look at the license plate again. If letters and digits cannot be repeated, then let's start with this first place. which is 2. We have a possibility of 10 numbers, 0 and then 1 through 9. We used one of the digits, so we have to remove that, which means for the next place, there are only 9 options because we used one of them. And for the next place, there are only 8 options because we've already used 2 of them. Remember, you cannot have anything repeating. For the letters, the first letter, you have the full alphabet to start with. You have 26 choices. For the second place, we already used one of the letters, so now we only have 25 options. And lastly, we only have 24 options. So when you multiply these numbers together, you multiply 10 times 9 times 8 times 26 times 25 times 24 as your options. The solution would be 11,232,000 different possibilities. That's with no repeating letters or digits. Next, let's take a look at the vocab word of probability. This is the extent to which something is probable, or the likelihood of something happening or being the case. So the probability of an event happening has a formula, and the formula is the probability of the event happening is equal to the number of ways it can happen divided by the total number of outcomes. So to put that in perspective, let's take a look at the first example. What is the probability of getting a heads when tossing a coin? So if we look at what our numerator is representing, it's the number of ways it can happen. So the number of ways we can receive the answer. Well, you have 2 choices. You have heads or you have tails. We're looking for the answer of heads, so the number of ways that we can receive the answer is one way. It's to receive or to flip a head when you flip heads or tails on a coin. The denominator is the total number of outcomes. So in this case, there are 2 outcomes. You could either flip the coin and receive heads as your answer, or you could receive tails as your answer. But there's 2 options. So the probability is found by setting up a ratio. The ratio of number of ways it can happen divided by total number of ways. Well, that would be 1 over 2, which is a 0.5% chance or a 50% chance that you would flip the coin and receive heads as your answer. I think that one's pretty self-explanatory. That's something we all know about. Let's move on to ones that would be a little bit more difficult. So independent events. These are 2 events. If the occurrence of one has no effect on the occurrence of the other. For instance, if a coin is tossed twice, the outcome of the first toss has no effect on the outcome of the second toss. This is called an independent event because each time you flip that coin, your answer is an independent answer. It is not based on your previous response or your previous answer. So if A and B are independent events, then the probability that both A and B occur is when you multiply your probabilities together. So basically you repeat this process twice and you multiply your answer together. We're going to look at an example of how we can use this. So the probability of an independent event. This says you are playing a game that involves spinning the money wheel shown. During your turn, you get to spin the wheel twice. What is the probability that you get more than 500 on your first spin and then go bankrupt on your second spin? Okay, so we need to analyze the spinner. So event A, we're going to say is this. What is the probability that you get more than 500 on your first spin? Okay, so I'm going to look at this. I'm going to highlight all the values that are more than 500. So starting, I know I already marked these for you, but starting right here, we have this option, which I already labeled as A. We have another option here of 650, 750, 950, 3,000, 900, 700, and 550. So that's 8 out of the total spinner. If you take a moment and count up all of the options on the spinner, there are 24 options. So event A is going to be 8 over 24. You have 8 possibilities out of a total of 24. Event B, you're going to spin the wheel and go bankrupt. I labeled these for you as well, but I think these are easy enough to see because they are red on the spinner. There's only 2 options for going bankrupt, which means you have 2 out of a 24% chance that you are going to go bankrupt. So the probability of these events happening in a row would be the probability of A and B, event A and event B, which indicates that you're going to multiply the probability of event A times the probability of event B. That means we are going to multiply 8 over 24. That's the probability of event A, multiplied by 2 over 24, which is the probability of event B. This is going to be 16 divided by 576. As a fraction, this simplifies. 16 goes into itself once, and it goes into 576 36 times. If we divide this out, we end up with approximately 0.028, which would be a 2.8% chance that this could happen. Approximately a 2.8% chance that this could happen. Okay, let's take a look at number 2. Find the probability that you will roll a 6 and then a 5 when you roll a die twice, which means you're rolling one single dice. So the first roll, I'm going to say the probability of rolling a 6. A dice has 6 sides, so you have a 1 out of 6% or 1 out of 6 fractional chance that you're going to roll a 6. For the second roll, the probability of rolling a 5 is also 1 over 6. For the total probability, the probability of getting a 6 and a 5 is when you multiply the probability of getting a 6 multiplied by the probability of receiving a 5 when you roll the die. Both our fractions are 1/6, so we're going to multiply these together to give us 1 over 36, which ends up being the same as what we just had on our last answer, but this is approximately 0.028 or 2.8% chance of that happening. Next, we're looking at dependent events, which some of you can probably assume what these are after we just went over independent events. So 2 events, A and B, are dependent if the occurrence of one affects the occurrence of the other. The probability that B will occur given that A has occurred is also the conditional probability of B given A and is written like this. So pay attention to the notation. So the probability of dependent events, probability of A and B happening would be probability of A multiplied by probability of B given A. Let's make sense of this by looking at an example. So the probability of dependent events, our first example says, you randomly choose a flower from a vase to take home. Your friend randomly chooses another flower from the vase to take home. What is the probability that you choose a purple flower and your friend chooses a yellow flower? before we start, I forgot to add a little bit of info for this problem. So we need to add that the total number of flowers is going to be 28. There's going to be 7 purple flowers. There's going to be 9 yellow flowers. And there's going to be 12 red flowers. So please add this info. We can't answer this problem without it. And I actually typed out what I have just so I can explain instead of spending all this time writing. So the first flower that is being picked from the vase is going to be purple. It's the one that in the description it says you are choosing a flower. There are 7 out of 28 flowers that are purple. So here's my ratio of 7 over 28, which simplifies to 1/4. After we pull the first flower, regardless what color we've pulled, there are only 27 flowers left. So the probability of pulling a yellow flower is 9 out of 27. There are 9 yellow flowers total, and there are 27 flowers left after you pull the first flower. So once you have these, of course, we should follow the correct notation, but once you have these ratios, you multiply them together to get your final answer. So if I was to write out the example, I would write it like this. The probability of pulling a purple and a yellow flower is the probability of pulling a purple multiplied by the probability of pulling yellow after the purple, which simplifies to 1/12. And 1/12 is about 0.08 or 8%. So you have an 8% chance of you pulling a purple flower and your friend pulling a yellow flower. For number 2, a bag contains 3 red marbles, 2 green marbles, and 4 blue marbles. 2 marbles are drawn randomly from the bag and not replaced. Find the probability that both marbles are blue. So the probability that the first marble is blue is 4 out of 9. When you add up the total of 3 plus 2, that's 5 plus 4 is 9 to give you a total of 9, and we know that 4 of them are blue. The second marble, we have a probability of 3 out of 8 being blue because we remove 1 blue, that leaves us with 3, and we remove 1 marble total, which leaves us with 8. So 3 blue are left over, 8 total are left over. Of course, this is just probability, so that might not happen, but we're looking at the overall probability that it could happen. So the probability of picking a blue both times would be 4 out of 9 for your first pick, and 3 out of 8 for your second pick, assuming you picked 1 blue. That gives us 12 out of 72, which is 1/6. So the probability of drawing 2 blue marbles is 1/6. Okay, please complete the on your own section by yourself, press pause. You can come back to the video and check out my answers against yours.